Hello everyone, welcome back to the channel. I hope you guys are doing amazing. So let's see today's daily challenge on Leetcode and try to solve it together. Uh, Maximum unique subarray sum after deletion of some element. So you are given an integer array nums. You are allowed to delete any of the number of elements from nums without making it empty. Okay, so you can't delete all elements. Otherwise, any number of elements you can delete. And after performing the deletion, select a subarray of nums. Okay, all the elements in the subarray should be unique and the sum of elements in the subarray is maximized. So you need to select the minimum maximum sum of elements that particular subarray you need to select. Okay, so if you try to think what can be the approach, so first of all you are deleting elements and then selecting subarray, so it is equivalent to selecting a subsequence. Okay, so you don't need to think that the elements are contiguous and stuffs like that. So I hope you know that in subarray the elements are contiguous and in subsequence the element may or may not be contiguous, but orders does matter. Okay, but you are deleting some elements and then selecting a subarray, so it's equivalent to selecting a subsequence. So what you can do exactly is that let's say you have an array of some 2 minus 1 6 0 6 5 minus 3 8. Okay, so let's say you have this array and you want to select some subarrays. You cannot select duplicate elements because the subarray must have the same elements. And what you can do is that you should not select these negative elements because they will lower down your total sum. So you should not select these negative elements. And there is no point of selecting this zero. There is no real point of selecting this zero. Okay, and you can select this 6 only once. Okay, so what you can do, first mark the numbers which you can select actually. So maximize your sum. So select 2, select 6, select 5, select 8, and you can delete remaining all the elements. So this element, all of the remaining elements you just delete. Whatever we will be left is simple. It is 2, 6, 5, 8. You just add them up. You just add them up. Okay. So, what do you see from this problem? What observations do you get? This is your answer, first of all. You easily understood this, I guess. So, it is nothing but 10 plus 11, which is 21. And this is your answer. But what will be a general approach? What can be a general approach? Will be that select all positive unique numbers. I hope you easily understood this, why exactly we need to do this. Select all positive unique numbers and add them and add all of them. So I hope you easily get it. We need to select all the unique numbers which are positive and we need to just add them. That is all you need to do in this problem. That is all you need to do. Now, selecting unique numbers, you can use a set. Okay, so let's say you are having a very long array where there are multiple occurrences of 2, 6, and stuffs like that. You are selecting first of all positive elements, but you need the two only once. You can add the two only once. So you can use a set. You can enter all of these elements in a set which will store each element exactly once. Okay, so I hope you know all this. So just we will do it. We have nums dot size. We have something like answer, which is initialized to 0. Now there is an important catch also. There is an important catch. So first of all, let's code it out first. Uh, let's say you have this set T, and for now you are going through all the elements and you are just checking that if this nums of I is greater than 0. Okay, so this needs to be greater than 0. Okay, then what you do, you just insert them into the set dot insert nums of I. It's as simple as that. You just insert them, and what you do afterwards is that for auto x, you just go through all the elements in set and just add them in the answer. You just add them in the answer. But do you think this will be sufficient? And if you just return answer, do you think this will be sufficient? What exactly are you doing here? You are just taking the positive numbers and adding them. But what if the array has all negative numbers? Let's say -5, -8, -2, -9. Let's say this is the array and answer variable is initialized to 0. It will see that this is less than 0. It will not add to the answer. It will again not add to the answer, not add. So answer will be 0, right? So what you are doing is you are deleting all the elements, but in the question it is told that you cannot delete all the elements. Okay, you are allowed to delete any number of elements without making it empty. So at max you can delete all, but remaining one element should be there at least. So what to do, so you select the maximum number. This -2 is the maximum. If all are negative, this -2 is the maximum element. So you just put your maximum element in the answer. So that's all. This is only the edge case that you need to think. So you also need to calculate the maximum element, int min. To calculate the maximum element, I am using the int min, and maximum is nothing but max of this nums of I. I hope you get it easily. Okay, I hope you easily get it, and there is no doubt. There should be no doubt about it. And you just see that if uh, this max element is greater than or equals to 0, then you just return max. Then you just return max, because that's all. And otherwise you just go through the set and take all the unique positive numbers and just add them up. So what is the answer which you get? You see you get an accepted here. And if you try to see the runtime complexity of this, it is actually 100%. Uh, but it might not be, okay, because you are using a set. Because you see there are 927 test cases. But if let's say there were more, a lot of them, then it could have been a little bit low, because you are using, what is the time complexity? You are entering all of the element at the worst case, and you will be using n log n. Okay, can you do it in O(n)? Can you do it in O of n? So in that case, memory complexity might not be that good. But what you can do is very simple, is that you can keep a visited array. Okay. You see, what you observe from here is that the elements are only of the -100 and 100, right? So maximum can be 100, and we are storing only positive integers. So I can use a visited array. Okay, of 101 size. It will tell me that whether a particular element have already been visited or not. And what we can do is very simple, is that we will check if nums of I is greater than 0, and visited, no, it is not visited. Okay, not visited of nums of I. So it means that that element is not, should not be visited. Then only what you do, you just add directly to the answer. Okay, so you just add that nums of I directly to the answer, and you also mark it as visited. If you are familiar with some graph problems, I guess this visited array concept would be very simple for you. And yeah, that's all. You do not need this loop now, and you can just return if the maximum element less than 0, return maximum. And what you can do also is that you just go through all the elements. If it is positive and if it is not visited earlier, then you can just mark it as visited and add it to the answer. I guess you will get a good runtime here also. I mean, this is O of n. You can easily, it is 100 into O of n, you can say, but this is mostly O of n. Okay. Uh, this is, it is not increasing any time complexity, but see, you see, there are some inconsistencies here. I actually improved the runtime complexity. You see, it is now giving 100%. Earlier it was just 37. So whatever be the case, you can easily understand that there is a single for loop here, and there is no set used here. There is nothing used here, and this is a much better solution. This is a much better solution. This is simple O of n solution. Okay, so that's all for this video. I This was a very simple problem. I hope you could have done it. If you cannot, then no need to worry. Just keep practicing on your own, and things will come automatically on your way. So yeah, that's all for this video. I will meet you in the next video, and I hope your day goes as easy as the problem. Thank you so much.